Hi everyone, in this video we are going to discuss the differences between a chemical reaction and a chemical equation. So the first thing we need to do is get some definitions down. So a chemical reaction is something that you do in lab. So in lab, it's also called an experiment. And so when I want you thinking of the phrase chemical reaction, I want you thinking of someone with goggles on, with a lab coat on, they're in lab, they're mixing things up, they're creating their bomb or whatever it is they're making, but they're physically doing something, they're making a chemical reaction. Now, when we want to talk about that or represent that on paper, that is considered a chemical equation. So chemical equation is on paper, okay? And it's basically a qualitative description. So when you think of a chemical equation, I want you to actually think of the most generic form of that, where you have reactants going to products. So this is the one that has the arrow in it. This thing that I just wrote out there, that is a chemical equation. Now, if I were to physically do this out, that would be a chemical reaction. So for example, my reactants could be any ingredients that you start off with. So let's say it's flour, maybe eggs, let's put some sugar in there, and then our product would be our cake or cookies or whatever it is we're trying to make. So our reactants are our ingredients, they're what we're measuring out, they're what we're physically putting into our bowl or our beaker and stirring it up, and then our products is our end result. So it's our new compound, our new chemical, or in our example here, it's your cake. So in lab or in the kitchen, that's your chemical reaction. On paper, the representative, that's your chemical equation. Now, I'm not going to get super upset if you mix the two words up, but if you continue on with a chemistry degree, there are certain professors that are very, very on top of this and very stringent, so you might as well get the vernacular down now. All right, so now I want to introduce a very, very important reaction, and so this is called a combustion reaction. A combustion reaction is essentially any time you have a fire. And so a generic version of this, or actually I guess a specific one, would be if the natural gas right here. So natural gas, which hopefully you can already name now from our last unit, we have one carbon right there, so that's going to give us the prefix of meth, and then we know that all hydrocarbons in this course are going to end with A-N-E. So this is methane. Now, for the combustion reaction, we always have some source of fuel. Okay, it can be a number of different things. In this example, we're actually just going to use a gas. So methane plus oxygen is going to create carbon dioxide plus water. Now, for this example, I chose to use carbon dioxide, so I'm going to describe a complete combustion. Sometimes we'll write it out as carbon monoxide, so one oxygen here, and that would be considered an incomplete combustion. So for this example, I have 1 to 1 to 1 to 1. I'm saying that for every one piece of methane, I have one piece of oxygen that's reacted, and we create one set of carbon dioxide and one set of water. In all actuality, that is not the case. In order for this to have a complete combustion, we actually need to have, for every 1 part methane, we need to have 2 chunks of oxygen. And then we create 1 chunk of carbon dioxide and 2 pieces of water. And so what I'm starting to do now is introduce these coefficients. But please note that all of these coefficients, so any of these numbers in front of the molecules, they can change readily based on your initial fuel. So if I change that up and use a different form of fuel, we would then have to be able to balance this equation using new coefficients. So let's try a new example. So that was natural gas. Let's try actual gas or gasoline, otherwise known as octane. So that is C8H18. We again are going to treat it with oxygen, and we will produce carbon dioxide and water. Now, in order to figure out exactly how much you need, is it 1 cup of this to 2 cups of this, or in other words, use ratios, or 1 part this, 1 part that, we have to use the law of conservation. Law of conservation of matter and mass. And all this thing is saying is that we cannot create mass. We cannot create matter. And so if we have 8 carbons on this side, we need to have 8 carbons on this side. So let's go up to our previous example and check this out. We have 1 carbon on the left side and 1 carbon on the right side. We then have 4 hydrogens on the left side, and 2 times 2, you multiply these together, we have 4 hydrogens on the right side. Now we can check our oxygen. We have 2 times 2, 4 oxygens on the left. We have 2 right here, and then we have 2 times 2. Okay, so this would be like there's literally a hidden 1 right here, so it's 2 times 1. Gives us a total of 2 right here. Oops, we don't want to lose the oxygen. But we have 2 oxygens from the water, and we have 2 oxygens from the carbon dioxide, so 4 total. So 1, 2, 3, 4, and then we have 4 on the other side. So from our initial example, we can see the law of conservation of matter. So now what we need to do is do the exact same thing here, and we need to balance our equation. So the first thing I do is I start with my biggest number. So I'm going to start with my octane over here. I'm going to start with my carbon, and I'm going to end with my oxygen. And the reason I'm going to end with my oxygen is because it's my only molecule that has the same element. So all of these here are at least compounds because they have a hydrogen and oxygen. But for my oxygen here, oxygen is my only element, so it's actually going to be easiest to end with this piece to adapt it. So let's start here. I have 8 carbons on my left side, so I need to have 8 carbons on my right side. So I'm going to add an 8 right here. Now let's check my hydrogens. I have 18 hydrogens here. I go over here. I have 2 on this side. So I need to make this number 18. So I know that 9 times 2 gives me a total of 18 hydrogens. Okay? So now I need to check my oxygens. I have 2 oxygens here. I have 8 times 2 here, so I have 16 oxygens here, and then I have 9 times 1 on this side, so 9. So 16 plus 9 gives me 25 oxygens on my right side. And this side, we said we only have 2, so I'm going to show you a trick. You need 25, so you do 25 divided by whatever that subscript is right there. So 2 times 25 over 2 gives us a total of 25 oxygens. Now, this is that thing right there. That is ugly. We do not like it. Yuck, we don't like it. So what you want to do is take whatever is in the bottom, so take that piece. You're going to multiply your entire reaction here by 2. So I'm going to come down below here and show you your final answer. So it becomes 2 pieces of octane plus, so 2 times 25 over 2, that gives us just 25 parts of oxygen, going to 8 times 2, so 16 parts of carbon dioxide, plus 9 times 2, which gives us our 18 parts of water. I just had a mind blank there. All right, so now we have our complete reaction. This is a balanced chemical equation, okay? So we are representing our octane chemical reaction, but on paper we're writing it out as a balanced chemical equation. So now what I want you to do is try a couple of examples on your own. So the first one I want you to try to balance is N2 plus O2 going to NO2. So take a second. Please do not rush. I want you to take your time. You absolutely have to master this skill before we can move on to the next part, because otherwise it's going to be really, really difficult. So just take a second and make sure you can understand this. So go ahead. All right, how did we do? Did we balance it? Hopefully. All right, let me show you how I would have personally approached this problem. So the first thing I do is look here. I have 2 nitrogens on my left side. I have 1 on the right side. We have to balance that out. So I'm just going to add 2 right here. But now what I've done is change my amount of oxygen. So I have 2 times 2, so I have 4 oxygens over here on my right side, and I only have 2 on the left side. So all I'm going to do is add a 2 right here. So what we end up with is N2 plus 2O2 going to 2NO2. So beautiful. Hopefully that makes sense. If it doesn't, please stop and ask your teacher right now, because we want to make sure we're on the next page. All right, so now I'm going to ramp it up a little bit. We're going to make it a little bit more challenging. So now we're going to look at ethene. So C2H4 plus oxygen going to CO2 plus H2O. First things first, hopefully you can look at this and go, okay, I have a source of fuel plus oxygen creating the product carbon dioxide and the product water. This is definitely a combustion reaction, okay? You need to start to be able to identify that immediately, so get used to this one. All right, now take a second, balance it, and then come back together. Okay, did we figure it out? Let's go through it together because this one was a little bit tricky. So I'm just going to get rid of all these dots and everything on the bottom to make it a little bit more clear. All right, so the first thing I would do is start off with my fuel and start out with my carbon. So I see that I have 2 carbons on the left side and 1 on the right side. So I'm going to make that a 2. Now what I see is that I'm going to have oxygens on both parts. So I'm actually going to jump right to hydrogens. I have 2 hydrogens on the right side, 4 on the left side. And so what I need to do is change this one. This is 4, so I need to make this one 4. So I'm going to add a 2 right here. So 2 times 2, that gives me 4 hydrogens on the right side, 4 hydrogens on the left side. So my carbons are good, my hydrogens are good. Now I need to balance my oxygens. So now I have 2 times 2, I have 4 oxygens here. I have 2 times 0, or sorry, times 1, 2 times 1, so I have 2 oxygens here. So 4 plus 2 gives me a total of 6 oxygens that I need to have on the left side. I have 2 on this side. I know that if I multiply 2 times 3, I will end up with a total of 6 oxygen. So now we have this absolutely beautiful, gorgeous combustion reaction. So I hope this is starting to make sense. Please take some time and practice this if it's not clear, because the next step is going to be unbelievably challenging if you don't have this down. Good luck, take care of yourself, and have a great day.